Okay, so just be quiet and I'll try and be fast. So we've got this equation shear as a function of y is equal to the shear force times the first moment of area divided by I times b as a function of y. Okay, so just remember that y is relative to neutral axis. Okay. All right. So is everyone happy with that? We've got an equation that can tell you what shear is. So remember that shear is complementary. So there's the horizontal and there's also the vertical component. And remember that if the vertical one is downwards, then you've got a horizontal component as well. And both of these are tau as a function of y. Okay, so is everyone happy with that? So we've got horizontal components of shear and we've got vertical components of shear, and they're all complementary and they all come out of this equation here. So remember that s dash y in this strange notation that's been given, s dash y is the first moment of area, and remember that I in this notation is the second moment of area. Okay, so is everyone happy with that? All right, good. Okay, so let's move on now. We've now got a slightly different concept, and this concept is in terms of Q. All right, so Q also as a function of y, and Q is exactly the same, V s dash y divided by I. So we can see that Q is also equal to tau as a function of y multiplied by the breadth of whatever portion we're after. Alright, so this one here is a stress, and this one here is a flow. And if you can get one, you can get the other. So they're sort of, you can sort of move between flows and stresses. Yeah? Newtons, I was getting onto that, so you've read my mind, newtons per millimeter. And the stress is newtons per millimeter squared. So we can see everything there that you need to calculate the stress is everything that you need for the flow. So if you had the flow, it's very easy to turn it into a stress, and if you had a stress, it's very easy to turn it into a flow. Okay? So have you come across flow before in any course? No? Okay. You have. Right. So is this a very weird concept to talk about flow? Is it a weird concept, or is it something you find very intuitive? So, I'm not very smart, so I normally just deal with stresses and I turn it into flows, and it saves me making a mess of stuff. Alright, so it's just really, you forget about the B, that's all. Okay, so in example 2 in the course notes, we were interested in, sorry, not example 2, yeah, in example 2, we were interested in putting some glue between the two planks. So that's obviously a stress. When you buy some glue, you want to know what's the shear stress of the glue. So you go and select your glue from the shop based on what stress they tell you that the glue can take. So things aren't always as simple as gluing stuff. So glue works well for timber, but I personally wouldn't go into a steel building that's been glued, and I certainly wouldn't go into a concrete building that's glued. All right, so real world, apart from living in the timber world, glue isn't such a great idea. All right, is everyone okay with that? So in the real world, we have to fight this shear. All right, just be quiet. Okay, that's nice. Okay. In the real world, we have to live with this shear, but in the real world, we use fasteners. Okay, so you go on an aeroplane and it's all riveted. So, okay, it's all riveted at precise locations. Or, even in the timber world, you can take 2 bits of timber and you can stick a nail through. So, in most cases, we're dealing with the idea of this shear flow because you don't really want to know about the stress. You want to know, have you bought a nail that can take the force? And the best way to get the force is to think in terms of shear flow. All right, so is that all fine? So with our nails, as we saw last time, along the longitudinal axis of the beam, you don't want to put a nail at every millimeter. So there will be a discrete spacing S between the nails. So you want to know the strength of your nail, and from the strength of the nail you can work out the spacing, or you're told what the spacing of the nail is, and can you work out what strength of nail you need to take. Alright, is that all very obvious? Okay, good. Okay, so let's move on. So we're now